Hello everyone, my name is Alicia Anglesey, and today I will be discussing Chapter 8 and the theories of color and vision. So first we have the introduction to differences that is important to clarify before we start. So there's subjective differences, which is anything that is described by the thoughts that are existing within someone's mind. Think your own personal biases and your own thoughts and your own feelings. Then you have your objective differences, which is anything or a statement that is not influenced by personal feelings. So then within those two, you have your individual differences that can change those. So, such as reaction time, that can play an important part in how people record their differences and their own results. So, next we have the Bell-Magneti law. So, that law concerns nerves and nerve theory. So, those first two reigning theories prior to the law was Descartes' theory, which he believed we had hollow tubes that connected to the brain that delivered the information, and Hartley's, which believed that vibrations to the brain and receptors was how we received information. So then these new theories were introduced by Charles Bell, who separated the nerve physiology into the study of sensation and movement, and Francois Magny, who published again similar results 11 years later. So then they kind of, gotten a little quaffle about that since Bell really only shared his results with personal friends and so had not published these results. So they kind of worked together. Next, we have Johannes Muller. Uh, he believed in different types of nerves had a different characteristic energy and required like certain types of stimulation or irritabilities. So they were sensitive to certain types of stimulation, like I said. So the eye can be stimulated with a blow to the head, but light waves are much more effective, and you're going to get a lot more responses than you were. So then the sensations that you experience in these objects that you see around you are determined by those senses and the adequate stimulation, also known as irritability. So he also believed that we are not conscious and we are only aware of our sensory impulses, such as using our sensory sensory things. I'll just say things in order to be aware of our environment and the things we touch, see, smell, and hear. Tests on nerve conduction found that responses are faster when a motor nerve is stimulated closer to the muscle, and vice versa, and when it is slower when it is farther away from the muscle. So a little bit more about their perception from Helmholtz. Uh, he said the previous experience of the observer is what converts a sensation into a perception. So that means previous experience seeing a chair means you had perceived the chair before. So the unconscious inference, he also stated, retinal image causes object to be slightly different on the two retinas, so such as his wonky lens perceptual adaptation experiment, where he gave people wonky lenses in order to see how quick they adapted to a different image, which he learned was very fast. So he also said you learn how to perceive, such as when blind people regain sight, they have to relearn everything they did before. It's not the same. So, like Kant said, the perceiver transform what the senses provide. So another theory, the young Humboldt's theory of color vision. So Newton had previously done some experiments with the color prism where white piece of light came in and lots of colors came out, so that the property of color was not in wavelengths but in perception. Helmholtz expanded on that, said there are three color receptors and the combinations of the colors give different color experiences. Next, we have a Wald Herrings, who developed space perception and color vision. Said stimulation helped lead to the fact that the retina provides three types of information: height, left-right positions, and depth. Space perception, he believed, was an innate characteristic, something that we were born with, and that color vision had three types of receptors: red-green, yellow-blue, and black-white. Another important philosopher, psychologist, theorist was Christine Ladd Franklin. After graduating, she eventually learned about Helmholtz's trichromatic theory of color, and she based that later on her evolutionary theory, well, based her evolutionary theory on the trichromatic theory. So she said the fovea is the most evolved part of the eye and was especially sensitive to daylight, visual acuity, and color sensitivity, and eventually concluded that there are three stages of evolution of the eye: achromatic vision, blue-yellow sensitivity, and red-green sensitivity. So some applications I found important where it is important because there were discoveries on perception and how people perceive themselves and the world around them that we should take into account. And it's also important to understand how biological operations fit into psychological understandings. And it's also important to understanding how sensory information travels. Here are my references. Have a nice day.